All right, conjugates, which went with one of our definitions of acids and bases from yesterday. So conjugates are part of the Bronsted Lowry definition of acids and bases. And in that, we're really looking at pairs. So a conjugate is an acid base pair or pairs where the compounds differ by the presence of one H plus unit. So it's not just going to be a difference between a hydrogen, either gained or lost, but it also has to be that charge, that +1. So that's going to affect what the charge of the compound that the hydrogen is gained or lost from goes to. So in this definition, an acid is a proton in the form of H plus donor. It gives the hydrogen, and base will be the one that accepts that hydrogen. So that's kind of why they are working pairs. So if we look at that first example, HF, hydrofluoric acid, is my acid. We said it's going to be a proton donor, so it's going to get rid of the H plus, and it's going to go from HF to just F. It was neutral, and now it has a -1 charge because it got rid of one positive particle. My water, on the other hand, went from H2O because it accepted that hydrogen, so it went from H3O with a plus, kind of hard to see. So not only did it gain a hydrogen, and my hydrogen went up to 3, but it was neutral and it gained something positive. So now it has a +1 charge. So these two go together, and these two go together. So if it is an acid on the reactant side, it's going to become a conjugate base. So if I have my acid, that's kind of just a general formula for an acid. It's going to give away that hydrogen. And on this side, it will become the conjugate base. So it starts off as an acid, loses a hydrogen, and becomes a conjugate base. My base, on the other hand, is going to start off as a base. We said it gains that hydrogen. So that means, kind of didn't leave myself any room here. Let me back it up a little bit. BH plus, that would be the conjugate acid. So if it's an acid as a reactant, it'll lose that hydrogen and it'll become a conjugate base, the opposite kind of conjugate. If it's a base, it's going to gain and it's going to become the opposite kind of conjugate. So sometimes you'll be asked to figure out an acid conjugate base pair, and I'll have some people, they'll say hydrofluoric acid and H3O plus. That differs by a lot more than just one hydrogen. I can't go from fluoride being into it to fluoride missing. So the only thing that it should change should be by one H plus. So this would be my acid and this would be its conjugate base. All it differed from was this H and the +1 charge. So in this reaction, the hydrofluoric acid donated the hydrogen ion and water accepted it. So hydrofluoric acid is referred to as my acid, and water in this particular reaction is a base. The fluorine ion, the fluoride, is referred to as the conjugate base of hydrofluoric acid. And now fluoride could accept a proton if this reaction was reversed. That's why it would be acting as a base. The hydronium ion is referred to as the conjugate acid of water. If I ran this reaction in reverse, now this hydronium would have an extra hydrogen and it could donate it. So in the reverse reaction, it would act like an acid. All right, so that's what we're doing just in this first little section. We're just labeling what they are. All right, so I have HCl. So it's either going to gain another hydrogen or it's going to lose this one. So my choice or it can go to H2Cl or it's going to go down just to Cl. So it goes from HCl to just Cl. So it donated a hydrogen. So that means it is acting as the acid. And this would be its conjugate base. Same thing for my water. If I start with water, it can do two things. It can go to H3O or it could lose a hydrogen. Those are my two choices. And in this reaction, I have the H3O plus. So that means the water accepted that hydrogen. So it's a base here, and then it would act as a conjugate acid on the other side. All right, why don't y'all label those two other little sections or two other little equations? So in my second one, what did my H2SO4? What was it, acid or base? Acid. Because it went from H2SO4 to HSO4. So that means it donated a hydrogen. That makes it an acid. And that would be its conjugate base. My water, on the other hand, it was the base because it went from H2O to H3O. It accepted that hydrogen, so it's a base, and this one is its conjugate acid. All right, on the next one, my ammonia, NH3, was it an acid or base? Base. Once again, it went from NH3 to NH4. So it accepted, and in this case, water was an acid. It donated, and it went from water to the hydroxide, which would be its conjugate base. So water can act as an acid or it can act as a base, and that is called amphoteric. And amphoteric is a substance that can act as an acid or a base. So it can either donate a hydrogen or it could accept a hydrogen. All right. So speaking of conjugates, how do they change? Because during acids and bases, we talk about a lot about strong acids, weak acids. So if I start off with a strong acid, and remember when we talk about acids or bases, if something is strong, then it ionizes. It doesn't exist as the intact compound. It exists as the ions. So if I have a strong acid, it will have a weaker conjugate base. So that one means here I would have ions. For my base, I would have a compound because it's weak. It's not going to ionize. If I have a weak acid, then I'm going to have a stronger conjugate base. That doesn't mean it gets as strong as our strong bases, but it's stronger than the ion. The base is more likely to ionize than the original acid. So it would start as a, compound, and then I would end up with ions. And same thing with my bases. If I have a strong base, which means it's going to ionize, it's going to be a weaker conjugate acid. So that means that conjugate acid will stay as a compound. And then weak base is going to give me a stronger conjugate acid. Once again, not necessarily into our list of strongs. So it's going to accept as an ion, and on this side, we would see a compound. So this is an indirect relationship. So that means if I had something like hydrochloric acid, that would be my strong acid, and it would ionize. So this is kind of like what we talked about yesterday. So this is going to ionize and form ions. This is going to be one of my stronger ones. All right. So let's just do a little practice because that's all we're covering today. So we will have a quiz over this on Friday. It'll have some that'll be reactions like you just solved, and then it'll have some, that are like these right here that we're getting ready to do. All right, so now we're given some compounds, some ions, and we want to know what their conjugate base is. So that means if I'm going to have a conjugate base, then eventually I have to say these are all acids. And they're going to give away a hydrogen to get from the acid to the conjugate base. So if we just start with water, if it's an acid, it's going to get rid of an H plus. So it's going to go down to OH. That's one less hydrogen, but it was neutral and now it's lost something positive. So that means it has to have a negative charge now. And that's sometimes the part that's a little bit harder for some people. NH4, once again, it's going to lose one hydrogen. So it would go down to NH3. It was positive and it lost that positive. So now it's neutral. All right, why don't y'all try the other couple on there? All right, C is nitrous acid. So what would it become as a conjugate base? NO2, and would it have a charge or not? -1, exactly, because it gave away one positive particle. And my acetic acid would become, yeah, it's the acetate ion, exactly. This part, because it got rid of this hydrogen, that's considered the acidic hydrogen, the hydrogen that's by itself. It went from neutral to a -1. And if you get stuck on the charges a little bit, if you had your ion sheet out, you could find these ions actually on that polyatomic ion portion, or even maybe sometimes at the top. So if you struggle a little bit with the charge, you could always check it there. Now this, we're going to have a conjugate acid, which means these all are starting as bases. So they're going to, instead of losing, they're going to gain an H plus. So HCO3 minus. So if that is my base, then it's going to gain a hydrogen. And it was -1. I gained something positive. So now it would just be neutral. So H2CO3. I thought I heard somebody. Try those last three and see what you can get. So you've kind of gotten the big part of the lesson. We're just going to finish out these examples. And are you not going to be here tomorrow? We're going to be using practice. All right, not recorded, but so the quiz over on Friday is over this. It's not over that. We'll have a quiz over that on Monday. All righty, y'all going to Austin? All right. Be careful. All right, so water became what? H2O became? Yeah, H3O, and it went from neutral to a +1. HPO4 would become H2PO4, and what would its charge be if it had a charge? Yeah, and that goes down to -1. And NH3 would become NH4 plus, that ammonium ion that we've kind of seen. All right, so we talked about water being amphoteric. It's kind of the big one that we mainly use. Another thing that could be amphoteric is if you had phosphoric acid. So at that point, it's not amphoteric. It's just an acid. It can only lose a hydrogen. But once it loses a hydrogen, it becomes H2PO4. And then it can lose another hydrogen and HPO4 -2. Those two are amphoteric because they both still have one more hydrogen to lose, so that makes them an acid, and then they both have room to gain a hydrogen also. All right, why don't y'all try those last three, just like we did on the front, label acid base as reactants and the conjugates as the products. And you can just use AB and CB and CA. You can use it on the quiz too. All right, on my first one, what is my HBr? A. So A over here, which means this would be as conjugate base. And then my water on this one is acting as a base. So I would have its conjugate acid over here. Once again, sometimes I'll have people that will try to pair this up with this. But if you look at those two, that's a lot more difference than just an H plus. So that is not considered a conjugate pair. All right, my next one, H3PO4 phosphoric acid would be A, and that makes my water my base. So over here, my H2PO4 would be the conjugate base or conjugate acid. Conjugate base, which this would be the conjugate acid. And once again, because if I ran this reaction in reverse, now that water has an extra hydrogen, is hydronium, so it could donate and this one would accept. So that's why they become the opposites. And my last one, CH3NH3, B. And here my water is acting as an acid. So it loses a hydrogen and this becomes its conjugate base. And this would be my conjugate acid. So not too terribly hard, hopefully. So y'all have a little time to do some practice. We will have a quiz over this on Friday. We're not doing the lab on Friday. I can just tell I'm not going to get my, whatever that place is, my lab cleanup. We'll do it on Monday. You can still bring your stuff that you want to test if you just want to remember. But we'll do the lab on Monday.